In this example, we're going to focusing on finding points that are on the graph of an equation without actually graphing the equation. So remember that if an ordered pair satisfies an equation, then that ordered pair represents a point that is on the graph of this equation. So really all I'm having to do here is verify that these points satisfy the equation. And if they do not satisfy the equation, then they are not points on the graph of that equation. So I have a specific example here. Let's look at the equation y equals x to the fourth minus the square root of x. And we're going to check 3 points, 0, 0, 1, 1, and 2, 4. So remember that in an equation that we graph in the xy coordinate system, we have x and y variables. And ordered pairs also come with an x value and a y value. So make sure that you're substituting the x value for x and the y value for y. So in this first point here, 0, 0, which of course is the origin, remember that the first coordinate is your x coordinate and the second is the y coordinate. So we are going to substitute 0 for x and 0 for y into the equation and see if it satisfies that equation. So 0 should equal 0 to the fourth power minus the square root of 0. So what I'm going to do is simplify the left and simplify the right separately and make sure that they equal each other. The left is already simplified, so I will just carry that down. The right side is where I need to do some work. So is 0 equal to, and I'll put a question because I'm not sure. 0 to the fourth power is 0. The square root of 0 is 0, and sure enough, 0 is equal to 0. So this first example is kind of boring with all of these zeros, but we can see that 0, 0 satisfies the equation. Therefore, 0, 0 is a point on the graph of that equation. Awesome. So let's check the other 2 points in exactly the same way. So let's check the point 1, 1. So I'm going to substitute 1 for x and also 1 for y into the equation. So is 1 equal to 1 to the fourth minus the square root of 1? And I put a little question mark here because I'm not sure yet. That's what I'm checking. So again, simplify the left, simplify the right separately. Do not move stuff from one side of the equal sign to the other. We want to verify that the left and the right are actually equal to each other. So again, the left-hand side is already simple. 1 to the fourth is 1. The square root of 1 is 1. So is 1 equal to 0? No. So the point 1, 1 does not satisfy the equation. Therefore, 1, 1 is not a point on the graph of the equation. Okay, one more point to check. Let's look at 2, 4. So again, the first coordinate is your x coordinate, the second is your y coordinate. So we are going to substitute 2 for x and 4 for y. Okay, so again, we're going to make the substitution and check if it satisfies the equation. So is 4 equal to 2 to the 4th minus the square root of 2. So again, simplify the left and the right separately. So is 4 equal to 2 to the 4th is 16. Square root of 2 is an irrational number. I cannot easily simplify. So is 16 minus the square root equal to 4? Definitely not. So again, I found another point that does not satisfy the equation. And if the ordered pair does not satisfy the equation, then it represents a point that is not on the graph of the equation. And that's it. All you have to do to verify that a point is on the graph of the equation, all you have to do is substitute in the ordered pair for x and y appropriately and check to see if it satisfies the equation. If it does satisfy the equation, that point is on the graph. If it does not satisfy the equation, then that point is not on the graph.